Okay, Introduction to Engineering Design. What we're going to be doing today is we're going to start going through Activity 1.3.4 CAD Modeling Skills. Most of this can be done with a Chromebook, so I don't really expect too many modifications to be made here for digital learners. And it's going to be about CAD modeling skills. And we've already done a little bit of CAD modeling skills. They're just going to teach us a few more tricks that go along with it. So what we're going to be mainly trying to work on here is using the loft feature, a tapered extrude, using a pattern, or creating a shell. And there are several different ways to do that. This lesson has the ability to use it in Fusion 360. We're going to be using that in Onshape instead. So let's go ahead and get started. And we'll also talk a little bit about injection molding as well too, whenever we get further down there, because there's a couple of tips and tricks, and we have an injection mold machine, so I'm going to teach you guys about it while I have the chance. Okay, so the first thing they want us to do is they want us to make a new file, and they want us to start a new design and name and store your design. Well, since this is 1.3.4 CAD modeling, I'm willing to bet that's what I'm going to call it. So I'm going to go to Documents, I'm going to go to IED Practice, and I'm going to create a document, and I'm going to call it 1.3.4 CAD modeling skills. It's going to be the easiest way to find it, at least in my book. So I'm going to click OK, and we're going to let that load. As it's loading, we're going to go back and look at the dimensions that it wants us to do. It says a 4-inch vertical by 6-inch horizontal rectangle. So we're going to go sketch mode. We're going to go to the top. Make sure that we're actually going to click on the top plane, top view. I'm going to make a rectangle, just any rectangle, and we're going to make it 6 across and 4 vertical. We're going to 4 by 6 rectangle like this. I'm going to hit, let's see if they want us to sketch anything else before I hit the green check mark. See what we got here. And let's see here. Looks like they want us to, oh, and yeah, if we use a center point rectangle, normally in Fusion 360, it will create 2 sets of construction lines automatically. I don't believe that actually works the same in Onshape. Let me go ahead and check real quick. You can click the center point rectangle by clicking the button on the rectangle tool right by it, and then moving down to center point rectangle. I'm going to try this. Yeah, see, whenever you create a center point rectangle in Onshape, it doesn't give you those nice fancy construction lines like it does in Fusion 360, unfortunately. So we're going to have to add those in. So I guess we'll use the line tool, and we'll go from corner to corner, and we'll go from corner to corner. Click, click. Hit escape to get out of the line tool, and then right click on each one of the lines and select construction. You don't actually want them as part of the rectangle, but we do want them there because we're going to be using them later on. So now we have 2 construction lines set up, and we're going to create polygons. Polygon, if you remember from geometry, it's just some kind of segments that connect together back. It's a closed loop. It looks like we're just making some regular polygons, which means that all of the links are the same. Fortunately, there are ways to make polygons that have all of the same side. So we're going to add 3 polygons inside of our sketched rectangle. So here we go. In Onshape, this is how we're going to do this. Our polygons, and it looks like they want us to do just 3 of them, and it wants us to make them I guess it just says inside your sketched rectangle, so we can put them anywhere you want to, I guess. So here's inscribed polygon and circumscribed polygon. And fortunately for us, it actually gives where the circle is for the inscribed polygon and where the circle is for the circumscribed polygon. So what you'll be making is for an inscribed, let's go ahead and try inscribed first. I'm going to click on that one, and I'm going to just click and then move my polygon out. Okay, and if you have it set to certain areas, you can make it, like for example, see how there's a dashed line that goes right here? This would automatically add a perpendicular constraint to the polygon. If you don't want that, you need to make sure that you don't have it snapped in place like that. Okay, so I'm going to click just right here. And once you click once, you can then move the mouse wheel up and down, and it will tell you like how many sides your polygon's going to have for that inscribed circle. So like the circle is on the inside, and if I add more sides, this polygon becomes more and more like a circle because you're having less equal sides to it. I'm just going to use 5 or use a pentagon. I'll click on that, and I'll have a, I think that's an inscribed pentagon. So we're going to now do a circumscribed. That's where the circle is on the outside. So I'm going to make a circumscribed um, polygon, and I'm not going to snap it into place, although you could easily get it to snap in place. So I'm going to just click right here, and I'll go ahead and keep it at 6 sides, so don't move the mouse up or down, just click 6, and we'll have a pentagon right there, or sorry, a hexagon right there. And I'll make one more, and we'll click, and then I'll move the mouse down to make a triangle. So we'll have 3 um, polygons here. 2 of them are circumscribed. The triangle is circumscribed because the circle is outside, and 1 inscribed because the circle is inside. Okay, inscribed inside is how I usually normally remember it. Circumscribed is the circle goes around, it makes a circumference around the polygon. Okay, so let's see what else it wants us to do, because we've got the polygon tool. Looks pretty cool, and it works out okay. Let's see here. A circumscribed, oh hey, look at this. Okay, so this is just a couple of examples. We've already done these. So for A and B and C, those have already been done. So no big deal there. All right. Use the following geometric and dimensional constraints to constrain the polygons. So we're going to have to add constraints on these polygons to make sure that they fit inside the sketch as shown. Okay, so the first one for A is the center of the pentagon is on a vertical line through the center of the rectangle. Doesn't necessarily say where it is on the center of the rectangle yet, but we're going to go ahead and put that in on the center of the rectangle. Well, let's make a construction line. So I'm going to hit the line tool and go to the very middle where it snaps into place, and then click on the other side. Hit escape so that you get out of the line tool, and right click, go to construction, and you've got a dashed line right there. Now we can apply our constraint. So I want this on the line. So I'm going to use the coincident button. I'm going to hit coincident. I'm going to click here in the center of the polygon, then I'm going to click on the line. And that's going to move my pentagon to the center of the rectangle vertically. Okay, next one. One side of the pentagon is horizontal and located at 0.5 inches above the center point of the rectangle. Okay, so one side is horizontal. Let's find the horizontal constraint. So I'm going to click on the constraint button, go to horizontal, and I'm going to click on one of the sides, and it should go into place. Okay, now none of this is locked down right now, so if it moved around, that's okay. And then we're going to add another constraint on it as well, because it says that it needs to be 0.5 inches above the center point of the rectangle. Now, remember, we can use this trick that we did last time. If you want this rectangle to be locked down, then we can also use the coincident constraint on the center of the rectangle, or you could just use a corner if you wanted to. So you can do coincident constraint and then click on the origin, and it'll lock it in place. So that way it's not going to start going around everywhere that you want it to. And you'll also notice that the border around the sketch is now black, so that means that it's locked in place. Okay, so we now can make a horizontal constraint. I can click and move this up out of the way. Since it's not really constrained, it's in blue, I can move this around any direction that I want to. And I'm going to click the dimensional constraint, and I'm going to click the horizontal line, and I'm going to click the center of the rectangle. And I think it said 0.5, so I'm going to type in 0.5, and then I think we're good right there. And let's see here. Yeah, that looks reasonable. Let's see here. One side of the hexagon is parallel with the 6-inch side of the rectangle. Hexagon. So we're looking at the other side. So we're moving on. So we're not on the pentagon anymore. We're going to be on the hexagon on the right side. So one side of the hexagon is parallel with the 6-inch side of the rectangle. Okay, well, my hexagon is all the way over there, so let's just take this guy and move it over. Oh no, look, see, look, it accidentally constrained itself over on this side. I have a small problem. Okay, but you can see how there is a coincident constraint right here. I can just click on that constraint and hit backspace, and it will go away. I did not want to have it there, but sometimes it does things that you don't want it to. Looks like it. Okay, now I really do need you to go away this time. All right, did it work? Okay, interesting. We're going to hit show constraints, and it looks like I have here's the one that I want. It's the one on the point right here. So I'm going to right click. I don't want to delete that. I just want to delete it using the backspace button. That should go away. I should be able to click and drag, and it really doesn't want to go anywhere. That's kind of disturbing. Um, great. Looks like I've got another coincident constraint up here. It's really locked into place. You know what? Worst case scenario, I can just make another hexagon. I don't need you, hexagon. I can just take another one whenever I want to. Oh man, okay, so this one really doesn't want to go anywhere. It's like stuck. Even if I delete the constraints, it's like, well, we're just gonna stick around. This is disturbing. I'm gonna keep trying and hurting myself in the process. Oh, that's disturbing. Yeah, it looks like I got rid of all of the coincident constraints around the around the hexagon except for this. Okay, this one's a wash. I'm gonna just delete this guy. This whole polygon is just dead to me. I'm gonna make a new one. I ended up deleting my constraints all the way around. So I'm just gonna go back up here, and it looks like it's just gonna be easier to just create a new circumscribed polygon. Be like, whoop, hey, look, a hexagon. I just kind of made that right there. Boom. Okay, back to the program. We're going to, I think it said it was parallel, so we're going to click the parallel constraint. Boop. And then we're going to make one of these sides parallel to the rectangle. Boop, like that. Okay, and I think sometimes it's beneficial to show the frustrations that people have with 3D modeling because sometimes things like that happen where you get things constrained and they automatically, like Onshape or Inventor, automatically assumes that that's where you want to put it, but that is really not where you wanted to put it. So frustrations happen in that case, and that's normal for this kind of stuff, unfortunately. Okay, so it says for the next one, the center of the hexagon is coincident with the diagonal of the rectangle. So I'm going to go back. I'm going to click the coincident constraint. I'm going to click the center dot, and I'm going to click on the diagonal part, and now we have it coincident with the diagonal. And if I click this and drag it, the hexagon shouldn't move like, shouldn't break itself apart, but we haven't set how big we want the hexagon to be, so we can move this anywhere that we want to. If we click on this point, we should be able to move the hexagon, but it's only going to be able to move on that diagonal line. It's not going to be able to move anywhere else. Okay, so we're going to go for the next one. Let's see. The one vertex of the equilateral triangle is coincident with the corner of the rectangle. Okay, well it said coincident, so let's use the coincident constraint. We're going to go down to the the triangle down. Oh God, where'd it go? We're going to go down to the triangle over here. I haven't, fortunately it's not, oh no. Why are you locked in? What are you locked into? Okay, whew. The triangle, we're going to make this have a coincident constraint. So we're going to click coincident, and we're going to click one of the edges of the triangle. We're going to click the corner, and it'll just kind of pop into place down there. So now that triangle can kind of move around, but this corner is stuck in place, so it's not going to be able to go anywhere else. So if I click that and drag it around, I can move this triangle, sure, but it's pivoting around this area. So we've kind of got it stuck. And do be careful, because if you are playing with this and you snap it into place, you're going to create a coincident constraint that you did not mean to make. So when you're moving these things around, be careful because 3D software is going to try to predict what you want it to do to try to save you time, but sometimes that is not time saving. Okay, so let's see here. The center point of the equilateral triangle is coincident with the diagonal of the rectangle. Okay, so all we need to do now is do the coincident constraint. We're going to click the center of the triangle, and we're going to click on the diagonal of the rectangle, and we now have our constraints put into place. We are in the right spots, I hope. Okay, so we've got all of those constraints done. These look reasonable as long as we have the right sizes. And I think we'll go ahead and we'll just put the sizes of the rectangles, dimension them in place. I think we can do that too. So that way we'll be consistent with what we have on our rectangle. So the last thing I'm going to do is I'm going to make the triangle have a side of 1.25. So I'm going to hit the dimension button to dimensionally constrain this. And we're going to say that that has 1.25. Click. Okay, that was actually pretty close, actually. Then we're going to do the hexagon with a 0.25. So I'm going to click dimensional constraint. We're going to go down to this bottom part. I'm going to do 0.25. We'll have a little rectangle, or a little hexagon. And the pentagon is going to have 0.35. So dimensional constraint. Go out to one of the vertices. Looks like I didn't hit dimension. Sorry. Dimensional constraint. Click, click, and then we're going to type in, I've already forgotten what it was, 0.35. 0.35, enter. Okay, so we've got a little pentagon, we've got a little hexagon, and we've got a not so little triangle. Okay, and it looks like we are pretty much good to go. I think if we wanted to, there's one more, like this one is black, this one is black, but the hexagon isn't quite black yet. So there's probably a little bit more that we could do to constrain this in place. Let's see what we've got. I think the only thing that can happen is this thing can just move up and down. And I notice that the actual links don't change anymore because I set them to 0.25. I think we're going to leave it there, though. I think we're just going to leave that in place so that it can move back and forth. I may regret that later. We'll find out. But that's going to be the end of part one. For part two, we'll start talking about how to put sketch patterns inside. But you guys have a great day, and we'll talk later.